It's Isan, Khadija, Zoha, and Lena. So there are many students who are not yet in the class. Guys, can you please turn your cameras on? ये दो बार क्यों बोलना पड़ रहा है हमें? Yes, Izan, Khadija, Lena, and Zoha. We have yes, Khadija, Lena, and Khadija and Zoha. Okay. Write a question. Determine the अच्छा एक सेकंड जरा रुकिएगा. Correct number 4 तक we ended ना. Valence electron repulsion theory. Then we directly started step number 5. Step number 6. ठीक है. Is like determine the hybridization electronic geometry and shape of the following. Write these 5 questions. Take 5 more minutes, guys, and then you will send me whatever you have done. Guys, you guys have 1 more minute. Kodeja, you have to give me everything, Kodeja. You have to give me the hybridization, you have to give me the electronic geometry as well as the shape of the column, not just the hybridization. But yeah, your answer for NS3 for hybridization, it is correct. Mm, okay, I would prefer the answer on my WhatsApp. Okay. Deja, please note down my number. Send the answers on my WhatsApp. And guys, please, whatever you have done till now, 5 minutes are over. You don't have to write that A and B thing. Okay, that is only for only when you have to think about any examples. Okay. Fine, Izan. You guys, please send me your answers on this number.
Okay,
Take a photo and send the answers, whatever you have done. Abdul Hamid, Izan, Khadija, Leena. No. Leena, your answers are wrong. It is wrong for H2O. It is wrong for hybrid NH3. Leena, did you practice anything that we have done till now?
Yes.
Yes, really. When I say practice, that means you have turned down the copy, you have closed your copy and tried to get the hybridization, to try to get the electronic geometry and molecular shape for the elements. Did you do that? Or you just read whatever we have done?
Red.
That is not practicing. How do we calculate the, keep your mic on, how do we calculate the hybridization? Tell me. How do we calculate the hybridization, Leena? Okay, Isan, no problem. Yes, Leena, tell me. How do we calculate hybridization? No idea. Flip some pages in your notebook and see how we have calculated hybridization. In the last to last class, I told you guys how to calculate the hybridization in steric number using the steric number. Who have just sent me? I don't have your number saved. My bad.
Me, sir.
No, Khadija. Okay, fine. Khadija, how did you get these hybridization and everything?
SP3, it is SP3 hybridization for H2O.
No, but how, I mean, like you remember everything.
Yeah, because even in my school, my teacher taught it, so she was like, just
Okay.
memorize it all.
What about the third case? It is SP3.
Is like this. I need to
Why? How it is
memorize that.
SP3? No, you don't have to remember ना, वही तो हम क्यों पढ़ा रहे हैं फिर हम? अगर आपको याद ही करना है तो फिर I would have not spent these 2 classes, right?
हाँ.
है ना? अगर आपको याद ही कराना रहता then there is a table in NCERT. वो हम टेबल दे देते, बोलते याद करना इसको और कुछ उपाय ही नहीं है इसका. Right? You don't have anything else, you don't have any other option, you just have to memorize it. There is no other option. But I spent like more than almost 2 days, complete 2 days on this. और फिर ये रिस्पॉन्स हो आप लोगों का कि हम याद करके आए हैं, तो आप लोगों ने प्रैक्टिस नहीं की फिर मतलब कुछ भी. यू गेट होमवर्क्स राइट, ये सुनो ना, किसी ने
Yes.
अगर आपने होमवर्क किया होता तो वहां पे आपको पता चलता लाइक हाउ टू डू इट. इफ यू आर नॉट गोइंग टू अप्लाई दीज थिंग्स देन इट इज नॉट गोइंग टू बेनिफिट. ठीक है, तो व्हाट यू नीड टू डू, आपको सबसे पहले इसका हम बता दे रहे हैं व्हाट यू नीड टू डू. और ये आई नीड दिस आंसर फ्रॉम एवरीवन टुडे इटसेल्फ आफ्टर द क्लास. ठीक है, for H2O you will find the steric number. You have the formula VMCA. From the steric number you will get the hybridization. From the hybridization you will get the electronic geometry. From the electronic geometry you will identify where you have the bonds, and from the electronic geometry you will get the shape. I will tell you for one of the cases, that is H2O. ठीक है ना, what you have to do. Please see here guys. For H2O, first of all, you will calculate the steric number. So steric number, it is equal to 1 by 2 divided by 1 by 2 into V plus M minus C plus A. VMCA plus minus plus. Now tell me, what is the valence electron of oxygen? V is the valence electron of central atom. Tell me, what is the valence electron of oxygen?
6.
6. Plus how many monovalent atom? How many monovalents are, you will have monovalents such as fluorine, chlorine, hydrogen. These are the general monovalent atoms that you are going to have, that you are going to see in the chemical bonding chapter for Vesper theory. So how many monovalent? That means those particular atoms whose valency is only 1. How many such atoms are present?
Hydrogen 1.
No, there are 2 hydrogens ना, तो उसको 2 लिख लेंगे. ठीक है?
Okay.
There are 2 hydrogens ना. So 6 plus 2, it is equal to 8 divided by 2, it is equal to 4. Now only the thing that you have to, even you don't have to remember anything. You have 4. How can you have 4 steric number? You will use S subshell. Wait, do we have? What other orbitals do we have? I have p orbitals, then I have another p orbital, plus I have p orbital. So 4, 1, 2, 3, 4, you have got it. If it was 5, I would add a D, because we don't have any other orbital. After S, we have P. After P, we have D. Is everyone getting my point? You don't even have to memorize. Now you've got the steric number, you got the hybridization, that is sp3. Now, sp3. For sp3, you have to memorize, even though it is logically explainable, why you are going to get the electronic geometry. The electronic geometry that you are going to, this is what hybridization, electronic geometry that you are going to get is tetrahedral. That means you will have oxygen like this. Now, in this particular electronic geometry, that is tetrahedral, TD, tetrahedral, we have 2 lone pairs here, and there are hydrogens like this. So what are these 2 rest of these things? These are going to be obviously the lone pair electrons. Okay, so we have 2 hydrogens, and the remaining will be lone pair electrons. So this is going to be what? This is going to be bent. You look at the atoms, hydrogen, and oxygen. So this is going to be bent. This is how you have to do the problems. If you are going to memorize, तो कितना memorize कीजिएगा आप? If I will give you SO3, तो SO3 अब ये कहाँ से memorize कीजिएगा आप SO3? How will you memorize this one? You cannot memorize for each and every atom. No? You will calculate the steric number. From steric number, you will get the hybridization. From the hybridization, you will get the electronic geometry, and then you are going to get the molecular shape. All of you understood how to do this? Yes or no? Please tell me, guys.
Sir, can you explain that V plus M minus C?
V plus M minus CA. You have seen the recording or did not watch the recording?
I did, but like, can you explain it again?
ठीक है, वैलेंस इलेक्ट्रॉन ऑफ सेंट्रल एटम. ठीक है, सेंट्रल एटम इट इज ऑब्वियसली गोइंग टू बी द मिडिल वन, जो बीच में रहेगा, जो कम रहता है, एक ही रहेगा. दैट इज गोइंग टू बी योर वाटर. H2O में ऑक्सीजन होगा. देन M इज नंबर ऑफ मोनोवैलेंट, ना कितनी हाइड्रोजन है, फ्लोरीन है, क्लोरीन है, तो दैट इज नंबर ऑफ मोनोवैलेंट. C is basically you are never going to use the C in your standard. I hope generally school वाले देते नहीं है cationic charge. So if there is a molecule that is having a cationic charge, तो उसमें आपको दिखना है the cationic charge on cation, and A represents the charge on anion. ठीक है?
Yes, sir.
But generally you will not have these cases. Cationic charge में there are two examples that we have done, NH4 positive and NO3 negative. ये दोनों examples में हमने steric number निकलवाया हुआ है, NH4 positive और NO3 negative. ठीक है, but नहीं मिलेगा आपको. अगर एग्जाम में मिल गया तो कर ही लीजिएगा, ऐसी कोई बात नहीं. Write this down. Write this down quickly. And by the way, I did not get any other answers. Only got answer from Khadija and Leena. What about we have here? Abdul Hamid, you did not send anything. Zoha, you did not send anything. इंसान आपने भेजा तो चैट नहीं भेजा. खदीजा, आपको बात समझ में आ रही है, क्या करना नहीं करना है? यस खदीजा. I'm not audible. All of you done writing? Yes or no? Please tell me.
No, sir.
Please write it quickly.
Sir, I'm done writing.
Let me know if anyone is still writing.
Done, sir.
After this, you're going to write. You're going to understand the formation of three important molecules, three carbon molecules: ethane, ethene, and ethine. Okay, please see here, guys. Write the topic. Formation of ethene. Now, first of all, what is ethane? Ethane will have two carbon atoms because it is eth. This must you must have learned about eth, ethane, methane, and all of these things in 10th standard, right? Alkane, alkene, and alkyne. So we have
Yes,
A and E. So obviously it is going to be alkane. So we'll have a formula C2H6. General formula is CnH2n plus 2. So it is going to be C2H6. And we can write it as CH3, single bond CH3. Now, the molecule of CH3 and CH3, it is going to be something like this. Carbon, it is going to have 4 bonds, right? It is going to have 4 bonds. So obviously, all of these bonds will be made by hybrid orbital, and since it is having only single bond, all of these hybrid orbital will be sp3 hybrid orbitals. All of these will be sp3 hybrid orbitals. One second, let me make it like this. Okay, so if you rotate it 90 degree, then you can easily see that if you rotate it 90 degree, you can see that it is so this is a tetrahedral only, है ना? आपको दिख रहा होगा ये इस तरह से, this is tetrahedral only, ठीक है? No, this is one carbon atom. The other carbon atom will be the same thing, but it will just be in the opposite direction like this. So these are the two carbon atoms. All of these are, there will be two electron like this, and all of these are sp3 hybridized orbital. And these two carbon atoms, this is having sp3 hybrid orbital. This is also having sp3 hybridized orbital, and all of these will be attached with a hydrogen atom like this. So this is the 1s of hydrogen atom. Also, you'll have hydrogen 1s, hydrogen 1s, and hydrogen 1s. All of these will be having some overlapping, and there will be two electrons in each of these bonds. So this is the structure of ethane molecule. Please write this down. Both of these carbon atoms are sp3 hybridized. Okay, both of these carbon atoms are sp3 hybridized. Let me know once you're done writing. If you're done, you will write formation of ethene. Please raise your hand once you're done writing.
Sir, what is the arrow in the middle?
Oh, these are the electrons. There are two, I mean, they will be bonded, no? So there will be two electrons. In all of these, there will be two electrons like this. Okay, but if you don't want to write, you don't write. I just showed it. Okay, but the structure will be like this. There's overlapping and there will be two electron pair shared, no? Each bond has two electrons. So that was the electrons. Okay, we show it by up and down arrow. Khadija, Leena, Zoha, what happened? Why your videos are still off? Please understand. Others, please raise the hand when you are done. You're waiting for Khadija and Zoha. Okay. Now, formation of ethene. Please see here, guys. Ethene means there will be two carbon atoms, and ene means it will be alkene. So the general formula for alkene is CnH2n. So it will be C2H4. And you must know the structure that it is going to have carbon, double bond carbon, and each carbon atom will have two hydrogen atoms like this. Now, when we know the structure of a particular molecule, you can lower your hand, guys. When you know the structure of a particular molecule, then you have to use this formula of steric number. Steric number, it is equal to number of sigma plus lone pair, right? So if I talk about this carbon atom and this carbon atom, then I have bonds like this. Hydrogen, 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 and hydrogen. As we know that carbon has 4 valence electron and it is already making 4 bonds, so there will be no you will be not having any lone pair electrons. So if I calculate the steric number for this case, we have how many sigma bonds? So a double bond is made up with sigma and pi. There is one sigma and one pi bond in the double bond. So we have one sigma here, two sigma here, and three sigma here. So this carbon atom is made up of three sigma. The other carbon atom will be similarly made up with three sigma bonds only. Okay, so here we can say that this is having steric number 3 and this is also having steric number 3. Now, can someone tell me when the steric number is equal to 3, what is the hybridization? What is the hybridization when steric number is 3?
sp3d.
Steric number 3 here, 3. I don't know where are you looking at, Isan. Steric number is 3. What is the hybridization? Please look in your notes. What is the hybridization when steric number is 3? You are looking at steric number 3, Isan.
Yes, sir.
No. Can you send me a photo? Actually, you don't have your phone right now. No one. What happened? Abdul Hamid, you don't have it in your notes. Lina?
3 sp squared.
sp2 बोलते हैं सर. क्या बोलते हैं? लीना?
sp2.
sp2. Okay. sp2 होगा एग्जाम देख लीजिए. I don't know where are you looking at. So both of these will be sp2, है ना? Now in sp2 we know that there will be 3 hybrid orbitals, right? 3 hybrid orbitals and carbon atom. One hybrid orbital will be like this. The other hybrid orbital will be like this. And then you will have the another carbon atom like this. So they will be bonded through the sp2 hybridized orbital. Okay, this will be hybridized, and these will be with the hydrogen atom like this. Now, this is all the sigma bond. This is also sigma. This is also sigma bond. This is also sigma bond. This is also sigma bond, and this is also sigma bond. But when I talk about the pi bond which we are having here, this pi bond will be made by pure p orbitals. As we know, carbon will be having s, and there are 3 p, right? So 2 of the p are making the sp2 hybridized orbital. There is one p orbital. There is one p orbital which is vacant, which is not in the hybridization. So it will be pure p orbital like this. I will make it with some different color.
Sir, how will we know if there is like 3p or 2p?
Where? In the hybridization?
Yeah.
There are 2 ways. If you don't know this, if you know the structure and the lone pairs and everything, then you don't have to worry. You can just add the sigma and lone pair electrons. Okay? Or just add the number of surrounding atoms and the lone pair. If you know the structure, how many surrounding atoms are there, how many sigma bonds, how many pi bonds, how many lone pairs in the central atom. If you know everything about it, then you just add the number of sigma bond and lone pair. Is that clear, Abdul Hamid? Okay.
Okay, sir.
Okay, one thing is that if you don't know, as was the case of these particular problems that I gave now, then you will go this route. Steric number से आपको पता चलेगा 4 है तो SPPP. अगर सिर्फ 3 होता, steric number 3 रहता, then you will have S, P and one more P. तो क्या हो जाता SP2. If the steric number was only 2, then you had S and then P. Got it?
Okay, sir.
This is the route that you have to travel. Now, here we are having, this is the pi bond, and this particular pi bonds will be these orbitals, these lobes and these orbitals. There are only, देखिए यहाँ पे लग रहा है 3 बॉन्ड बन जाएगी, ठीक है ना, but please understand it is not 3 bond, it is only 1 bond. ठीक है, so this is one complete atomic orbital, this is one complete atomic orbital, they are interacting like this. ठीक है, interacting like this, and this is the formation of one pi bond, and this is the structure of ethene molecule. Is that maybe we have not done?
Sir, won't this pi bond have those like sigma bond like the circle?
Circle means, I mean, what's overlapping?
Yeah.
And they will, but I can't show it ना.
Okay.
हमने वो ऐसे ऐसे कर दिया. Okay, I can't show it ना, मतलब अगर उन दोनों को हम चिपका दे बिल्कुल तो बहुत ही अजीब सा स्ट्रक्चर बनेगा, आपको कुछ समझ ही नहीं आएगा कि क्या हो रहा है. It will be like this, इतना चिपकाना पड़ेगा, तो कुछ तो सेंस नहीं बन रहा ना, राइट? So जैसे इसको, ठीक है, इस पे ऐसे रखा है. But there is another structure that you can draw, that when they are going to overlap, तो overlapping के बाद कैसा दिखेगा, that you can write. कि मान लीजिए ये ओवरलैपिंग हो गई, तो उसके बाद ये जो पाई बॉन्ड्स हैं, they will be like this. इस तरह से यहाँ पे इलेक्ट्रॉन डेंसिटी, दिस इज, अब ये तो और समझ में नहीं आ रहा कि क्या है, दो नया चीज है. दैट इज व्हाई आई recommend this structure. तो यहाँ पे पता चलेगा that we are having interaction between these two orbitals. Okay, now this structure must be given in your NCERT. If you look, this is the structure that they have given. Again, this also does not make too much sense when you look at it for the first time. जिनको ये बनाना है, they can also make this one, but both of these structures are valid. ठीक है, both of these are valid. This is one pi bond only. ठीक है, this is one pi bond. Write this down quickly. Quickly, guys, write quickly. Yes, Izan, it can be. It can. This just shows that these two hydrogens are connected to the carbon atom, nothing else. लिखने में ऐसा कुछ खास रोल नहीं है. You can write it as H2C also. In, yes, I don't know whether you know about it or not. In organic chemistry, whether you know the difference. When you are having ionic molecules, there you have to write in this manner that you have Na and then Cl. Only this is correct. You cannot write ClNa. Okay, this will be wrong. But for organic structures where we have, or rather I should say the covalent structure that we are having, in that you can write in many ways. For example, we write POH whole thrice. This is also fine. You can write it as H3PO3 also. This is also fine. Okay. So when we are having covalent bonds, in or covalent structures, molecules, then in that case we can write it anywhere. Okay. If everyone is done, then we are going to write the next one, formation of ethyne. Formation of ethyne. So ethyne, that means we have two carbon atoms. They will write C2, and ethyne, that means we have alkyne. So it will be CnHn. So hydrogen will be also 2. So carbon has 1 hydrogen. So rest of the bonds will be here with another carbon atom and 1 hydrogen. So in this case, if I look at this, both of these carbon atoms are having 1 sigma, and there are 2 pi bonds. So number of sigma bond that we are having is equal to 2. And because carbon is using all the 4 valence electrons, because it is making 4 bonds, so आपके पास lone pair कुछ है नहीं. There are no lone pairs. So steric number will be equal to how much? Steric number will be equal to number of sigma. Sigma plus lone pair. Right. So how many sigma do we have? 2. And how many lone pair? 0. So steric number is 2. अब बताइए, what will be the hybridization? Tell me guys.
SP.
2 है तो sp. ठीक है ना? That is it. We have sp and sp. अच्छा, when we are, see, carbon atom will have s subshell and it will have 3 p orbitals. It will have 1 s orbital and 3 p orbitals, out of which only sp it is forming what hybrid orbital. So there are 2 p orbitals which are not taking part in the hybridization, and they are in their pure form. Okay, they are in their pure form. So first of all, we will write the hybrid structures. The hybrid orbitals here, we have carbon. So this is one of the hybrid orbital. The hybrid orbital, and then I have the another carbon atom. So these are the 2 carbon atoms that we are having, and they are making bond like this. So I'm just talking about the carbon. This is the sigma bond now, and then the hydrogen sigma bond and hydrogen sigma bond here like this. Now when I talk about these 2 p orbitals, so I will make the p orbital p, borrow the p from here. Okay. So this is one of the p bond that we are going to have. Erasing this part because I need to draw one more. ठीक है, तो आपके पास ये एक p हो गया, है ना? One of the p orbital. What about the other p orbital? The other p orbital will be like this. Again in 90 degree. So rotate what? Flip first of all vertically, and then flip horizontally. Yeah. Okay, so we have this another p orbital. Let's make it a bit bigger, and it's also a bit bigger. Similarly, we are going to have the p orbital for this carbon also. So the sigma bond is made by the hybrid orbitals. The pi bond is made by these p orbitals. These p orbitals are making one of the pi bond, and the other pi bond is made by the green p orbitals. इसको हमने green से लिखा, चलिए green हो गया. This green. These are the interaction of the green p orbital which is making another pi bond. आपके पास एक तो पाई बॉन्ड ये है और दूसरा पाई बॉन्ड इस ब्लू वाले से यहाँ पे. This is the structure of ethyne molecule. Both these carbon atoms are sp hybridized. Please write this down. Raise your hand once you're done.
Sir, how will you know like if it's 0 lone pair? Like there is 2 hydrogen, right? So there should be 2 lone pair.
No. We know the structure. We know the structure ना. आपको मतलब
Yes.
structure से तो कोई दिक्कत नहीं है ना. Triple bond, single bond से कोई दिक्कत नहीं है.
No, sir, no problem with that.
एकदम ना. कितनी बॉन्ड बना रहा है कार्बन एटम?
2 bond, right? Like
नहीं, 2 बॉन्ड कैसे बना रहा है? एक तो ट्रिपल बॉन्ड है, तो यहाँ पे 3 और एक 4 बॉन्ड बना रहा है ना? नहीं,
okay.
4 से आप कंफर्म है ना? 4 में तो आपको दिक्कत
Yes.
नहीं है। आई होप यू आर
Yes,
ओके
sir.
विद द आइडिया ऑफ ट्रिपल बॉन्ड, राइट? ठीक है,
Yes, sir.
तो 4 बॉन्ड अब आपको समझ में आ गया। सो आई मीन इस बॉन्ड के लिए इसने एक इलेक्ट्रॉन अपना दिया होगा, इसके लिए एक इलेक्ट्रॉन, इसके लिए एक इलेक्ट्रॉन, 3 इलेक्ट्रॉन तो यहीं पे हो गए। एंड द फोर्थ इलेक्ट्रॉन इज हियर व्हिच इज फॉर्मिंग अ बॉन्ड विद हाइड्रोजन एटम. So if it is having 4 valence electron, it is using all the 4 valence electron in the bonding itself. तो lone pair कहाँ बचा? Got it?
Okay. Okay, sir.
ठीक है, please raise your hand once you're done. All of you understood this? Yes or no? Please tell me. अब्दुल
Yes, sir.
हमीद वगैरह सबको समझ में आया? जोहा, लीना, आपको समझ में आया?
Yes.
Waiting for Izan and Khadija. Waiting for Izan and Khadija. Just waiting for Khadija now. Khadija, please let me know quickly. Others, you can lower your hand. Only if you guys please lower your hand. Just waiting for Khadija now. Okay, Khadija is done. Okay, guys, all of you please lower your hand. Abdul Hamid, Khadija, Khadija, सबको please lower your hand. After this, you'll write the topic bond parameters. ठीक है, right? Bond parameters. Bond parameters की जब, हाँ, guys, lower your hand. ठीक है. When we are talking about the bond parameters, then we are talking about 3 main things. और 4 चीजें वैसे तो होती हैं, चारों चीज के बारे में आप लोग लिख लीजिए यहाँ पे. And we are going to explain the 4th point later on. ठीक है ना? Bond parameters में, right? We will talk about bond length. We will talk about bond angle. And thirdly, we are going to talk about the bond strength. ठीक है, एक 4th point होता है bond order. ठीक है, this is mainly a concept of molecular orbital theory, but we are going to have just a slight look here. What is bond order? Bond strength, and the bond strength can also be written as bond energy. If you see bond energy, or if you see bond dissociation energy, bond dissociation energy. All of these 3 terms, they mean the same thing, है ना? Bond strength, bond energy, and bond dissociation energy. First of all, you are going to write the bond length. Please write with me. Bond length. Okay. So what is bond length? Please write. It is the equilibrium distance between the centers of 2 nuclei of bonded atoms. in a molecule. So equilibrium distance के बारे में अगर आपको कुछ लग रहा है, like what is equilibrium distance? So when we are having bond between A and B, so this bond is actually not like a typical fixed thing. It is more like a spring. Okay, so there are, I mean, A and B, these are attached with a string, so they can wiggle a bit. Okay, so there are some type of movement which can happen in a bond, and when you are having some spring-like thing, then obviously there will be some movement with A. A will be having some particular distance which it can move or wiggle around or vibrate at least. For B also, there will be some allowed space in which it can vibrate, because already, obviously, there will be some temperature, right? There is some temperature present. So because of temperature, things can move, atoms can move, and that atoms are always vibrating. And equilibrium distance means what is the middle position here? If this is one extreme, this is the other extreme, what is the middle position? That is the equilibrium distance. So from here to here will be the bond length. Okay, we are not going to take this much, or neither we are going to take this much. The equilibrium distance, that means the middle one. Okay, so this is the meaning of equilibrium distance. Okay. After this, you are going to write factors affecting bond length. This is more important. Factors affecting bond length. Factors affecting bond length. Now, in factors affecting bond length, first of all, you are going to write the size of atoms. Right, number one, size of atoms. So bond length, it is obviously directly proportional to size of atoms. When we are going to have two small atoms and there is overlapping, see the bond distances will be very small. Bond length will be very small. But if I have large atoms like this, the bond distance obviously will be what? Larger, as we can see. The bond size atoms which are in the bond formation, and atoms of the bond, the atoms are taking part in the bond formation. So if I go down a group, for example, I am talking about carbon-carbon bond, and then I am talking about silicon-silicon bond, and then I am talking about, let us suppose, germanium-germanium bond. Then obviously the germanium-germanium bond will be largest, followed by silicon-silicon, and then we are going to have carbon-carbon because it is smaller in size. So regarding size of atoms, this is the first factor. Right, the next factor after size of atoms, bond multiplicity, or we can also call this as bond order. But how many bonds are we having? We are having a single bond or a double bond or something like that. So the bond length, it is inversely proportional to the bond multiplicity or bond order. Okay, or bond order. What is bond order or bond multiplicity? It is just as we are having, if it is one or single bond, if it is single bond, then it is going to be what? Then it is going to be one bond order. Bond order is equal to one, or bond multiplicity is equal to one. If there are double bond, then it is two. So if we have more bonds, there will be more attraction between E and B. If I have a single bond, so there is little attraction. If I have two bonds, then there is more attraction. So things are going to get more closer. If I have one more bond, then there will be more attraction, and the things will be the bond order. As the bond order increases, the bond length will decrease because there will be more attraction. That is why I can say that in case of carbon, so if I carbon single bond and I compare carbon double bond and I compare carbon triple bond, then the carbon triple bond will be the smallest, followed by carbon double bond, and the carbon single bond will be the largest because there is only one bond. Similarly, you can compare nitrogen also. Nitrogen single bond will be largest, followed by nitrogen double bond nitrogen, followed by nitrogen triple bond nitrogen. And for oxygen, you can compare as oxygen single bond will be longer than oxygen double bond. Oxygen triple bond cannot be formed. Right, bond multiplicity. After this, you are going to look at bond angle. Now, first is what is bond angle? Please write. It is the average angle between the orbitals containing bonding electron pair of central atom or around central atom. Ca is central atom in a molecule. If I have something like this, if I have A which is bonded to two B atoms, because we are talking about this particular angle. This is the bond angle. This is the bond angle. Yeah, this is the bond angle. So after this, we are also going to write the same thing as for bond length, factors affecting the bond angle. So these are obviously more important than the definition itself, factors affecting bond angle. Now, I want all of you guys, you can first of all turn your mic on and then flip to page number, like whatever page you have, steric number 2. And all of you go to steric number 2 and turn your mic on. All of you please go to steric number 2. Steric number 2. You must have it in your notes. Steric number 2. सबको मिल गया? अब्दुल हमीद, इजान, खदीजा, लीना. All of you got steric number 2? अरे बोलो यार, जल्दी बोलो, मिला नहीं मिला, हाँ या ना, जल्दी बताए ना. अब्दुल हमीद, yes or no? Abdul Hamid got steric number 2. Abdul Hamid, you got steric number 2. I mean the section steric number 2 where I have explained the example is that. You have written in the notes.
Yes, sir.
From the ठीक है आपने लिखा. Abdul Hamid, are you not there? Khadija, did you get steric number 2? Khadija, अरे माइक ऑन करो ना यार, क्यों आप लोग डांट सुनना चाह रहे हो हमसे? Khadija, am I not audible? Why is the mic off? Why is your mic off? Abdul Hamid, अच्छा आपका mic खराब है. Okay. What is the bond angle in steric number 2, guys? Tell me. Write in the chat, all of you guys. What is the bond angle in steric number 2? जल्दी 10 तक गिनेंगे हम. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. ठीक है, एक आंसर आया, सिर्फ बाकी लोग पता नहीं क्या कर रहे हैं. बॉन्ड एंगल नहीं है किसी के पास. अल्लाह करे आप पे, क्या ही पढ़ रहे हैं आप लोग, पता नहीं. ठीक है, वेरी गुड ईजान. जिसने देखा उसी को समझ में, आगे किसी को नहीं समझ में. अल्लाह करे. ठीक है, देखिए. नाउ ईजान, गो टू ऑल ऑफ यू गाइस, गो टू स्टेरिक. जिसको एंगल, बॉन्ड एंगल क्यों नहीं भेजा आप लोगों ने? यू डोंट हैव बॉन्ड एंगल. खदीजा, आपने बॉन्ड एंगल नहीं लिखा है स्टेरिक नंबर 2 के लिए. यस खदीजा, तो फिर भेजिए ना चैट में, क्या हो रहा है आप लोगों को. गो टू स्टेरिक नंबर 3. Go to steric number 3. Is everyone there? Steric number 3.
Yes, sir.
Again, those who are there, please send the bond angle. What is the bond angle in the chat, please? Steric number 3. What is the bond angle? What is the bond angle in steric number 3? Yes, Abdul Hamid, correct. Steric number 3 में ईजान ने नहीं लिखा है bond angle. Steric number 3 में ईजान गलत लिखा है आपने. जो भी लिखा है एक बार देख लीजिए क्या लिखा आपने चैट में. I hope you have not written that in your notebook. 180 लिखा है आपने. क्या यार, आप पढ़ाने का मन नहीं खत्म हो जाता है बिल्कुल इस तरह से. तो यस खदीजा, ईजान 180 लिखा है आपने.
Yes, sir.
हाँ ईजान, कैसे 180 लिखा है यार आपने? What is the bond angle?
Oh,
यस लीना, ध्यान से नोट्स बनाइए. चलिए steric number 4 में बताइएगा. Steric number 4 in the chat please. Steric number 4, what is the bond angle? You will take the case of CH4. You will take the case of CH4. Yes, Abdul Hamid. Yes, Izan. Izan सही से नहीं लिखा आपने, ठीक है, हाँ, but still it is nearby. Okay. ठीक है, चलिए एक चीज हम लोगों को देखा. This year, guys, when the steric number was 2, the bond angle was 180 degree. When the steric number became 3, the bond angle was 120 degree. When the steric number was 4, the bond angle became 109.5 degrees. As we can see, if I take the case of steric number, if I talk about the steric number, you see here, first is steric number. If I talk about the steric number, the factor effect is bond angle. Then as the steric number, what is happening? The steric number is 2, 3, 4. क्या हो रहा है? बढ़ रहा है, घट रहा है? Increasing रे भाई, increasing. Steric number is increasing, and bond angle is
decreasing.
Decreasing. So we'll write as the steric number increases, bond angle decreases. ठीक है. Now there is something that I want to teach you guys. ध्यान से सुनिएगा लिखने से पहले. Don't write anything. When we have the steric number 2, my hybridization is sp. When we have steric number 3, it is sp2. When we have steric number 4, it is sp3. We are having sp3, sp2, and these things. I am erasing these parts here. Okay, please see. When we are having the sp hybridization, this hybrid orbital will be having 50% s character and 50% p character. Is that clear? Yes or no? Please tell me, guys. Because sp is made up of what? It is made up of s and p. एक s है उसमें और एक p है. So obviously it is going to have 50% s character and 50% p character. When I go to sp2, here you can see we have 3 s, p, and p. So what will be the percentage contribution? 33%, 33, and 33. The total should be 100. आप लोगों को बात समझ में आ रही है? Yes or no? Please tell me. Or I can at least say like this, na? If I have sp2 hybridization, then 1/3 part, 1/3 part, and 1/3 part. This is the contribution. I am only focusing at the S subshell here. I'm only focusing on the S subshell. So if I talk about the S subshell in the sp2 hybridization, then we can say that it is going to have only 33% contribution. When I talk about sp3, then we are having S, P, P, and P. So 1/4, 1/4, 1/4, and 1/4. So if I talk in the terms of percentage, this will be 25% contribution of the S orbital. Is that clear? Yes or no? Please tell me. यहाँ तक clear है सबको?
Yes, sir.
अब यहाँ पे we can say that as the S percentage decreases, bond angle also decreases. दिख रहा सबको? हाँ या ना?
Yes, sir.
So we will write as the S percentage decreases, bond angle decreases. So steric number or this particular factor can also be known as or the percentage S character. आप ही जल्दी से let me know once you're done. Guys, you please read the notes daily. If you are not going to read the notes, आप लोग भूल जाएंगे चीजों को. ठीक है? Okay, Abdul Hamid is done. Those who are done, you write the next factor. Lone pairs central atom. First of all, we are going to look at steric number. ये ध्यान रख लीजिए बिल्कुल आप लोग. That first of all, the first thing that we are going to look whenever we are going to compare the bond angle, we are going to look at the steric number. After that, we are going to look at lone pairs. After that, we are going to look at lone pairs on the central atom. I want all of you guys, please go to the steric number 4. Steric number 4. Steric number 4. In that, we have 3 cases. We have 3 cases, and there are 3 different examples for which we have written the specific bond angle. Please go to steric number 4. Please go to steric number 4. And we have 3 cases. What are the molecules in those 3 cases? Please tell me, guys. Steric number 4, case 1, case 2, case 3. What is case 1? What is case 1?
Carbon and
Both
hydrogen.
कार्बन एंड हाइड्रोजन नहीं है, CH4 होगा. Isn't it CH4 guys?
Yes, sir.
Case 1 CH4 the example देखिए है ना, it will be AB4 obviously है ना. I understand it will be AB4 sir. वहां पे तो लिखा हुआ है कि there are 4 sigma bond and 0 lone pair electron है, क्या है कुछ भी नहीं. But example CH4 is there. What is the example in the next case, case 2? क्या example है?
NH3.
Very good. It is NH3. What is the example in the third case?
OH2.
H2 नहीं है, H2 बोलेंगे उसको है ना.
हाँ, H2.
ठीक है.
Yeah.
ठीक है. This is sigma and lone pair. I'm talking about now sigma. So this is having 4 sigma, 0 lone pair. I hope you can see that in the case 1. In the case 2, we are going to have how many sigma? We are going to have sigma 3 and 1 lone pair. And here we are going to have 2 sigma and 2 lone pair. All of these are having the hybridization or the steric number 4. It is the case of steric number 4. All of these are having steric number 4. But what is the bond angle of CH4, guys? Please tell me. What is the bond angle of CH4?
109.
109.5 degrees. ठीक है. What is the bond angle of NH3?
107.
107. What is the bond angle of H2O?
104.
104.5 degrees. ठीक है. Now, as you can see, as the lone pair is increasing, bond angle is
Decreasing.
decreasing. So what we are going to write? Bond angle. It is inversely proportional to. It is inversely proportional to lone pair on central atom. My bad. नहीं ठीक है, my bad. ठीक है ना, बॉन्ड लोन पे. हाँ ठीक है. ठीक है. But please remember, you are going to check the lone pairs on central atom only and only after checking the steric number. This is only true when you have the steric number same. If the steric number is same, then only this particular thing is true, right? Only when steric number is same. If we are if obviously you will be having some comparison. So when you are comparing things, you will compare the lone pairs on central atom only after you have compared the steric number. If you have not compared the steric number, you will not talk about the lone pairs. Can I move on?
1 minute, sir. I'm writing.
Okay. Third is electronegativity. So when we talk about the electronegativity, when we talk about electronegativity, then there are 2 different cases that we have to see. Okay. So electronegativity is right. Electronegativity. When the central atom is different, but surrounding atom is same. Or the other case will be, there are only 2 cases which are possible. First case, you can have the central atom is different, but the surrounding atom is same. Other case that you can have is when the surrounding atom is different, but central atom is same. Surrounding atom is different, but central atom is same. Okay. Now, when the central atom is different, but surrounding atom is same, then the bond angle, it is directly proportional to the electronegativity of surrounding atom. Okay, electronegativity of, sorry, my bad. Surrounding atom is same, no? Central atom को देखेंगे, central atom, electronegativity of central atom. Okay. So obviously, which is same, it is not going to affect the bond angle. And अगर कोई चीज same ही है दोनों में, both of the molecules which we are comparing, they are having same surrounding atoms. So obviously, surrounding atoms are not going to determine the bond angle. The bond angle will be determined by the central atom, which is different. And here, when we have surrounding atom different, but central atom is same, the bond angle will be determined by the surrounding atom, because those are only different. Whatever is different, that is going to have any effect. It is inversely proportional to the electronegativity of surrounding atom. We will see two examples here. In examples, you can have, let us suppose you have H2O versus H2S. You have H2O and H2S. So each and everything is same here. If you count the steric number, it will be same, because oxygen and sulfur, they are having the same. Oxygen and sulfur, they are in the same group. Then if you talk about the steric number is same. उसके बाद अगर आप बात कर लीजिए लोन पेयर भी दोनों में क्या रहेंगे, दो लोन पेयर रहेंगे दोनों. Each and everything is same, but only the electronegativity is different. So if you compare, पहले इसको qualitatively समझते हैं थोड़ा क्या हो रहा है. Oxygen atom and then hydrogen here. Sulfur, hydrogen. So which is more electronegative, oxygen or sulfur? Any idea, guys? Which is more electronegative, oxygen or sulfur?
Oxygen.
Oxygen is more electronegative. Very good. So if oxygen is more electronegative, it will be pulling electron density, and the electrons will be nearer to the oxygen atom. Correct? Right? Correct. Oxygen
Yes,
atom is more electronegative. Okay. So if the electrons are nearer to the oxygen atom, so obviously, can you see the electron pairs? They are itself very near, because अगर मान लीजिए they are very near to the oxygen atom. इस तरह से आपके पास ऑक्सीजन एटम है, राइट? थोड़ा अगर हम बड़ा कर लें, ठीक है, इस तरह से ये तीन जगह, लेट अस सपोज द इलेक्ट्रॉन इज लाइंग हियर एंड हियर. ये केस तब होता व्हेन द सराउंडिंग एटम वाज हैविंग मोर इलेक्ट्रोनेगेटिविटी. दूसरा केस आप ले लीजिए व्हेन द इलेक्ट्रॉन्स आर कंप्लीटली इन द मिडल, when you have electronegativity which is equal. And take the last case, which is our case, where the electrons are very near to the oxygen atom. ठीक है. अब आप डिस्टेंस देखिए जरा, look at the distance. So in the blue case, which is our case right now, when the central atom is more electronegative, when the central atom is different in the two molecules, and the central atom which is having more electronegativity, it is pulling the electron density towards itself, and thereby making the making the bonded pair electrons more near. If the bonded pair electrons are more near, then they will repel more. सबको they are going to repel more ना. यहाँ पे blue वाले केस में सबसे ज्यादा repulsion होगा. And if they are going to repel more, then obviously they are going to repel करेंगे ऐसे, तो ये बढ़ जाएगा. Bond angle क्या हो जाएगा? Bond angle बढ़ जाएगा. जब bond angle बढ़ जाएगा, so obviously what we are going to say, bond angle is like this. और यही लिखा है, bond angle is directly proportional to the electronegativity of central atom. जिस central atom का electronegativity ज्यादा, उसका bond angle ज्यादा. All of you understood this case? Yes or no? Please tell me. ये समझ में आया सबको?
Yes, sir.
ठीक है. अब उसी से आपको ये भी समझ में आ जाएगा जो हम अगला केस लेने वाले हैं. प्लीज हियर गाइस. अगले केस what is going to happen? We are going to have this type of case, है? चलो यार इसको हटाओ, छोड़ो. It is inversely proportional to the electronegativity of surrounding atom. In this case, you are going to have example of NH3 versus NF3. So in this case, the surrounding atoms are different, but central atom is same. Both of them are having nitrogen itself. So we are going to compare the electronegativity of
NH3.
surrounding atom. जो different होता है उसी को compare करेंगे, ठीक है? So nitrogen, NH3 is like this, and NF3 is like this. So obviously fluorine is having more electronegativity, तो fluorine के पास electron रहेगा ज़्यादा. अगर fluorine के पास electron रहेगा, so obviously electrons are very far away. If they are very far away, there will be zero repulsion or very less repulsion. और NH3 के केस में तो इलेक्ट्रॉन कहाँ रहेंगे? इलेक्ट्रॉन्स यहाँ आ रहेंगे. नाइट्रोजन के पास ऑब्वियसली यहाँ पर रिपल्शन ज्यादा होगा. दैट इज व्हाई this will be the order. हटा देते हैं. This will be the order. NH3 will be having higher bond angle. Is this clear? Yes or no? Please tell me, guys.
Yes, sir.
Write this down quickly. If everyone is done, then we are going to write the next point, that is the bond strength. Please write the heading. Bond strength or bond energy. Okay. Please write here. Amount of energy required to break one mole of bonds of a particular kind between two atoms in gaseous state is called bond dissociation energy. ठीक है, bond dissociation energy, bond energy वही सारी चीजें एक ही चीज है. ठीक है. So obviously if there are two atoms which are having a high bond strength, दोनों के बीच में bond बहुत मजबूत है, the bond is very strong, so it will require more energy to be broken, है ना? So we can write what bond strength is directly proportional to bond strength directly proportional to bond dissociation energy. After this, we are going to write the same thing as we have written previously. Factors affecting. Please write these things with me.
Sir, what is
bond
BDE?
strength, bond dissociation energy. Bond dissociation energy. Puteja, your internet is not proper. You are getting disconnected very often. Puteja and Zoha, both of these girls. Okay, so in factors affecting bond dissociation energy, you write the first factor, which is, please write with me, size of atoms which are taking part in the bond formation. Okay. Now please see, but you will write here bond dissociation energy. It is inversely proportional to the size. If we are having large size atoms, their valence electron, which are very far away from the nucleus, है ना? यहाँ पे आपके पास nucleus, यहाँ पे इसका nucleus है. So obviously the valence electron which are taking part in the bond formation, they are very far away from the nucleus. That is why they cannot have too much effect on the nucleus, and that is why the nucleus will not be as attracted. अब इस केस में देखिए, when you are having small atoms, यहाँ पे जो दो न्यूक्लियाई है, दे आर वेरी नियर बाय ईच अदर. तो ऑब्वियसली जब दो बहुत ज्यादा नजदीक होंगे, देन देयर विल बी मोर अट्रैक्शन. इफ देयर इज मोर अट्रैक्शन, देन द बॉन्ड स्ट्रेंथ विल बी हायर. There will be more strong bond when the atoms and the nuclei are closer to each other. So bond dissociation energy is inversely proportional to the size of atom. Second point that you are going to write, it is basically speaking the same thing. Bond length. Bond length. So bond length, it is also, I mean, bond length किसके proportional होता है? Size of atom पे, right? So we can also write here same thing. Bond dissociation energy, it is inversely proportional to the bond length. क्योंकि size of atom बढ़ेगा तो bond length obviously बढ़ेगा. Okay, so these are the two simple factors. Write the third factor which is important. Bond dissociation energy, that is bond multiplicity or bond order. Bond order या multiplicity जो बोल लीजिए आप, multiplicity. Okay, so if I have only one bond between, easy to break. If I have two bonds between that, it will be difficult. If I have three, it will be more difficult. Right? So I can directly write here that bond dissociation energy, it is directly proportional to the bond order. जितना ज्यादा bond order होगा, उतना ज्यादा difficult होता जाएगा bond को break करना. Is this clear till here? Yes or no? Please tell me, guys.
Yes, sir.
ठीक है, अब देखिए एक जरा एक केस है आपके पास, प्लीज राइट नोट. If you compare F2 and Cl2, ठीक है, F2 and Cl2, then obviously the size of fluorine is smaller and the size of chlorine is larger. So expected हमारे पास क्या था? If I see the fluorine versus chlorine case, then the expected thing that we had was, please, F2 versus Cl2. What was expected? Expected was F2 should be having larger bond dissociation energy than Cl2. But the actual thing that we see by data can be easily broken, and Cl2 has higher bond dissociation energy or higher bond strength than F2. So why is the case? The case is this because if you look at fluorine, then fluorine has a single bond. Fluorine also has a single bond. But fluorine has 3 lone pair electrons. Chlorine also has 3 lone pair electrons. Then only it is what having 8 electrons in its valence shell. But chlorine has a larger size of atom. So if it is having larger size of atom, it can easily accommodate these lone pair electrons. They can easily accommodate the lone pair electrons. But fluorine is very small. अब बहुत छोटी जगह में if you are going to put too many lone pair electrons, if you are having a large number of electrons, the electron itself will be repelling each other. And because of this electronic repulsion in the fluorine atom, which happens because of its small and compact size, which happens because of its small and compact size, it is very easy to break the fluorine molecule. So why it is this the case that expected is F2, that means fluorine should have higher bond strength than Cl2 because of the size. But the size is the one. Size is the factor, which is the reason fluorine is having lower bond strength. है ना? क्यों क्या हो रहा है? Because it is having more lone pair electrons, और छोटी जगह में lone pair electrons है तो वहां पे repulsion हो जा रहा है, right? This is due to small and compact size of fluorine, which cannot accommodate 3 lone pair electrons, 3 lone pairs, and hence can be easily broken. So please write this down. Let me know once you're done. Insan is done. What about others? write this quickly. There is one more topic. Please write next. Resonance. Right, resonance. Okay. So what is resonance? This will be only understood if you have done the Lewis dot structures with me. If you did Lewis dot structures with me, then let me just remind you guys. Second class, it must be second or first class. Yeah. Look here in the NO2 negative molecule, CO3 2 negative molecule, right? And CO2 molecule also you can see. In these cases, if you look at the structure NO3 negative, this double bond which we are having between nitrogen and oxygen, वो इधर भी हो सकता था. Nitrogen, double bond oxygen and single bond oxygen like this. I have written it like this also. Time up क्या? मेरा time up नहीं होता है. Time up ऐसा बोल रहे जैसे मेरा एग्जाम चल रहा है. एग्जाम हाँ तो गई थोड़ी देर. ठीक है एग्जाम. आप लोग जो टाइम पे नहीं आते हैं वो टाइम अप नहीं है. आप आ गए थे टाइम पे, बात सही है, लेकिन बाकी बच्चे नहीं आते ना. Okay, Izan, you can handle some 5 more minutes. जी ईजान, टाइम अप भूल रहे हैं. टाइम अप कहां से होगा? मेरा तो ना टाइम अप होगा. टाइम अप. चलिए सी. So resonance structures will be, for example, you have NO3, NO2 negative, right? We had NO2 negative. So it was, we can write the double bond oxygen here. This is one of the structures. Or we can write it like this also. Nitrogen's double bond oxygen here and a single bond here. Okay, so when the structure, it is not completely explained by only one Lewis dot structure. अगर हम सिर्फ इसको देखें, so we cannot explain the structure in its completeness. We can only explain this NO2 negative structure when we have the two structures. Now, look at this Lewis dot structure की जरूरत पड़ रही है. There are two Lewis dot structure that I have to make for this case, and then only I can explain all the behavior of NO2 negative. That means originally, if I talk about NO2 negative, it is neither this structure nor it is this structure. It is somewhere in between. Oxygen, oxygen, and both of these bonds that we are seeing, these are partial double bond. Partial double bond. And the negative charge here. That is why we have to have two different structures to explain it. Similarly, if I have CO3 2 negative, so we have seen one structure, carbon double bond O. There are single bond, oxygen and oxygen. And this is having two negative charge. Now, obviously, this particular structure is not the only structure. We can write the CO3 2 negative structure somewhere like this also. Please see. Ignore this double bond. We can have the double bond with this oxygen also. There is no difference. We can also have one more structure, which is this structure. All of these three structures are going to explain the complete CO3 2 negative. And neither of these structures are real. We are going to use one of these structures by the use case, जहां पे ज़्यादा property show करेगा. But neither of these structures are real. All of these are hypothetical structure, and these are known as resonating structure, resonance structure, or canonical structure. These are different names. So what is the original structure of CO3 2 negative? It is the hybrid of all of these three, which is something like this. That all of these three bonds they are neither single nor double, rather all of these are partial double bond. Now, if they are partial double bond, then what is the effect? As you can see, if I only look at one structure, तो हम बोलेंगे, अच्छा, one, if I talk about the carbon oxygen bonds, if I'm looking at only one of these resonance structure, ना सिर्फ हम first वाले को देख रहे हैं अगर, then I will say there is one carbon double bond oxygen, and there are आपके पास one, that means one, एक, O, and there is two of carbon single bond oxygen. But this is not the reality. When scientists they checked the bond length and the bond strength, then neither of them showed the bond length of double bond length, nor of no one showed the single bond length. दोनों ने, यानी कि whatever bond length we were seeing for carbon and oxygen, we were getting only one value, and that value was between the double bond and single bond. That is why we concluded that it is having partial double bond character. Okay, so when we are having structures which cannot be explained by only one Lewis dot structure, rather we have to make multiple Lewis dot structures to explain it. We call that particular phenomena resonance, and the structures that are the individual structures, we call them resonating structures. And then we have the hybrid, which is the real resonance hybrid structure. The resonance hybrid structure. All of you understood the resonance hybrid structure? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Okay. So first of all, ये देखिए resonance resonating structures. या कैनोनिकल स्ट्रक्चर